move on now to the last talk of this session, which will be given by Professor Andrew Hursthouse from the University of the West of Scotland, near here in Paisley. And he's going to look at the sort of European context of anthropogenic and geochemical factors in urban environments.
Great, thanks a lot, Fiona, and thank you for the invitation to come and bring some of our data into this forum. And I hope there are enough links to some of the presentations we've already had this afternoon in particular. And I just want to make a quick advert for some of the additional fora that we discuss this in Society for Environmental Geochemistry and Health and various other medical geology societies regularly gather to debate and discuss this particular set of issues around urban and human urban environment interaction. And if you're quick and fancy a trip to Newcastle, there's an event happening at the end of June, beginning of July, and if you plan ahead, we've got meetings in Bratislava and possibly Brussels in a few years' time, and there's a big jamboree in Perth, Australia in 2016 if you really want to save up. So the topics that have been already raised this afternoon are very current with us. What I want to do is perhaps pick up on some of the work on soil that we've been doing, and particularly urban environments, and put it in the context of both human health but also ecosystem health, and some of the discussions that are happening in other cost actions. And these slides have been exposed to people looking at cost meetings on urban allotments and also green infrastructure that link very much to this particular theme in cost. So perhaps I'm not necessarily good value for money. I'm a cheapskate in terms of selling our research to different audiences, but perhaps there's a little bit of cross-fertilization we can get from that. So that's partly the reason for my tree-hugging photograph in the program biography. So I do love humans too. Okay, so quickly to run through a bit of background work, why urban soils. We've heard a lot about it already, but in particular they're very, very unique in that you and I are continually exposed to them. We create them, we transform them. They're partially naturally, they're very disturbed. We don't know much about them, but we do know that we interact with them increasingly so, and the descriptions of urbanization and population increase and population density in urban environments is always placed in the context of increasing and higher and more. So they are becoming increasingly of importance to creating an environment or maintaining an environment that's healthy for us. We've already had from Marion a view in terms of broader urban systems, but we really have very little background information, and the GBASE data set is a very important step forward, and other geological surveys contributions to that as well. But they're unusual materials. They're outside our normal domain as far as soil scientists are concerned, but in terms of planners and managers of urban environments, they're very important in terms of exposure to potentially harmful substances. And I did think that our introduction this morning, when you were welcome to the deer green place that is the origin of Glasgow as a very, very nice lush point on a river, is perhaps emphasised now as another deer green place after John's description of chromium-3 and its abundance in Glasgow soils. But anyway, in terms of remediation, it's also important. But perhaps the urban function and the discussions we have about more sustainable urban environments is something to think about. And that's my excuse to bring sort of trees and humans together a bit in this discussion. The soils, as we've already seen, most maps have this grey or black or undefined shading in urban environments. I'm afraid I've just got a Google stolen picture of Southampton, but it could be Glasgow. But urban soils, by definition, they are loosely defined and very variable. And the picture on the left-hand side is full of all the elements of urban soils. It has mineral material, has organic material, it has space, and it has moisture. Unfortunately, the organic material is tarmac. Most of the mineral is brick and concrete. So it's still functioning as a soil in many respects, and the geoengineering community would just think in terms of strength, I guess. But the definition is one we continue to discuss, and I could take all afternoon to debate. The most important thing is that the environment is under stress, under pressure, under human intervention. It's been created by humans, and it's going to be changed through human agency. And again, the regeneration process, but also the normal, whatever normal is, urban cycle will continue to stress that. And I think the point that John Redshaw made about change, I picked this up in a few years ago, as I thought it was a really nice reflection on the situation. It's, we can't rewind what's happened to Glasgow and most of our urban environments through this wonderful progression of industry, but particularly environments that are developing very rapidly, such as we have in China and other regions, and as was reflected earlier on today in Africa, and what the picture might look forward to might look like in the future is something perhaps we can reflect and contribute from this very group. And here's I think it's a fantastic little study where a group looked at the development of a very rapidly developing city in China, and located places where they could collect samples of soil that had been sealed at particular points in time, and from that recreate, if you like, a contamination rate, if you like, of urban soil for different elements. And you see here these fairly good lines. Fairly good, strong, positive gradients, and again, that doesn't disagree with perhaps our concept of what urbanisation might be all about. So, also looking at things like tree rings, etc. But in terms of temporal impacts, in terms of growth of urban, that's one interesting thing. But what happens when it stagnates in growth or redevelops is another question altogether. Okay, so what I want to do, I'll throw some examples in. The deer green place, oh gosh, this wasn't planned, but when you intersect blue and yellow, what do you get? So Glasgow was involved in two separate projects, a more widespread urban soil project we were involved with in a framework program, and a smaller Bulgarian Academy of Sciences forestry and urban environments project that is just coming to an end. So within that zone, Glasgow was involved in a major way, and colleagues in Glasgow City Council facilitated a lot of access to the sites that we looked at. So the Herb Soil project was very much looking at public open space, looking at the quality, defining the context for the chemical status of that particular type of soil, and it was involved collaboration between 6 cities, a number of research teams in those cities that contributed broadly across the east to the west and the north to the south of the sort of western bit of Europe. So not as inclusive as it could have been, but enough to get the cash. So we had a broad geographical perspective from that. We looked at harmonising methodologies. We didn't follow the methodology for GBase, but we followed a fairly well-agreed consensus approach to samplings of soil. So before anyone asks how these compare to the GBase, they don't compare directly, but within the data set they show the comparisons. And that is really what we wanted to look at. The work in Bulgaria was very much looking at the storage of carbon and the quality of urban soils and the threat of urbanisation on green infrastructure, and perhaps the long-term response that many urban planners might want to consider in using that infrastructure for improving well-being in urban environments or preserving it. So yes, a very mixed set of data, so I'm going to go through some of the points that have come out from that study. I've cut out a couple of the slides that might have been useful. People have asked about POPs and PCBs, PAHs. We have a whole raft of published material on that, which I can direct you to, but we'll stick to some of our favourite potentially toxic elements, the metals of interest in urban systems that have been discussed already. And particular, studies that we undertook, and this is just a very small, simple pilot study. Each of the teams were tasked with obtaining a piece of public open space, a park in the centre of a city that, to the knowledge, to the best information available, had been undisturbed for as long as possible. So the oldest parks and the oldest gardens in these urban environments, and in those environments to collect in a systematic way a series of spot samples and analyse them using a harmonised and quality assured process. It was an aqua regia extraction with ICP OES analysis. So this is what we got in terms of box plots. This shows the variability of the same land use using broadly using the same analytical methodology from city to city. So you can see some variation, and yes, Glasgow reflects very well in terms of being at the top of the contamination index. Copper, zinc and lead used in this context. Chromium was not as significant in these open spaces as we might have anticipated, knowing all of the issues around chromium in the Glasgow area. But you can see again this variability. Single land use, single site, well within the single sampling points that perhaps would be used in the GBASE survey. So the spacing, 50 samples in one park, about 25 metres apart. Okay, so perhaps this is some of the finer variability in the broader survey data set that we might be getting through. And then if you perhaps reflect on this in terms of particular elements, and we had a group that had a very, very, very nice new mercury analyzer. So they did all the analysis for this, so any analytical bias was restricted to the quality assurance in one lab, and they processed all of the samples. And this shows for mercury in undisturbed soils the variability in the concentrations, and there are no known industrial inputs, so this must be from the natural deposition rates of urban environments for mercury. And you can see just from the spots, I know you can't read the concentrations so well, the relative concentrations, so just put up the range there in bold type. The other interesting thing, those geometrically astute amongst you, is that the regularly spaced grid request was only won by 2 teams. Okay. And we all had GPS and we all worked very well. The students were pretty good by the time we'd driven them out to the sites. But what that also reflects is, particularly in Glasgow, we were really embarrassed. We had a lovely, lovely, massive green space, Glasgow green. But we couldn't meet the criterion that we needed to find an undisturbed piece of ground. Simon's guys sent us a geophysics plot that showed all the buried air raid shelters and swimming pools full of PAH tar that meant we couldn't go over to half of Glasgow green, so we had to split our way into that. But it also reflected that in other places, urban land use shapes, forms are not homogeneous, as you might expect, so people had to bend their way around concrete paths, and where the GPS said you should go, you couldn't. Okay, but anyway, so some variability, the context just for one element there. And in terms of perhaps what impact the city has on soils, this is another study. It's not Glasgow, but it's from a city of very similar historical evolution in terms of industry, in terms of surrounding geology perhaps. And you can see here a set of plots coming in from outside the city into the city, and you can see, even without the helpful dotted line, that there are significant changes in content, particularly pH, and Fiona had already mentioned in terms of the inputs of concrete and building material, and again perhaps the homogeneity and the stabilisation of the pH you can see up there. Okay, so how do you get a feeling for the strength of those inputs? And very simply, just to sort of finish off some of this work, looking at the multi-element data using simple factor analysis, or it's not simple, but quick look through PCA, you can identify a number of components that are associated, and you can get some sort of diagnostic information from that. And so we've got mixtures of natural the underlying geology that's already been mentioned, but also the anthropogenic inputs. And when you start to look at the land use types, the gardens, the public open spaces, riversides, roadsides, they're all defined differently in each city, but generally we try to put them together. You find that, for example, between Glasgow and Aveiro, we have here the gardens and public open spaces, riverbanks. We always find very strong pollutant signatures or significant dominant pollutant signatures in a large city, but Aveiro, which has a much lower level of industrialization, that is lost in some of the land uses. So it does matter what sort of city you're in terms of the source and the strength and association of the different factors. In terms of bioaccessibility, we also, thanks to John for introducing this very elegantly earlier on, I'll just say that we looked at whether or not the significance of the high concentrations for lead, or what the significance might be for the high concentrations of lead we found in some of the soils, and if you do some extraction techniques that allow you to mimic human ingestion, then you can start to perhaps play with the numbers to see whether or not the extractable material could be significant for consumption. So, the answer is that if you're a small child, you might be at risk if you ate over half a gram a day of some of the nastiest soil in Glasgow. Half a gram isn't so much. Okay, so a question, what are the environments and the likely environments we might create to allow that to happen or not allow it to happen. Going back to the trees, my friends, another receptor, if you like, but in terms of stabilizing environments to create healthier environments, we do find that in urban forests, the urbanization effect does mobilize some of the potentially toxic elements, and they are taken up. And for lead it works. We heard earlier on about the pH control in surface waters, and yes, in soils the availability increases with decrease in pH, and it accumulates in the biomass. So it is mobilizable. It's not going to kill the tree. Lack of water will probably do that, or dog fouling or something nasty in terms of people hanging on branches. But in terms of the resilience of these environments, perhaps we need to think a little bit more about the buffering that the soils can offer. And it also makes an impact on the carbon stock in terms of management of these environments as well. That's other work, it's another story, and it's sort of in press at the moment. So in terms of some conclusions, urban soils inherently more variable. I think we've seen that this afternoon already. We've got a very good resource in terms of the survey data showing on a wide spatial scale the variability in identifying hotspots. But within smaller plots, within public open spaces, we can start to also ask questions about the relative contribution that these soils might make to the human exposure. Land use in Glasgow, beautifully summarised in the pictures on the side. I would rather hug a tree than run along the side of a motorway, and I can't play football. So thank you very much for your attention, and that's it. Thanks.
Excellent data set from China that showed the increases in heavy metal concentration of time as the city expands. But really picking up on the question earlier that John from Super gave, what's the natural capacity of the environment to get rid of this stuff, to normalize after you stop the industrial processes and the urban expansion?
Depends on how you use, I guess, how you use that environment. I think what was quite interesting to see with, and I'm not going to rerun the talk, but to see with the Turin example is that there is a strong signature chemically in the urban soils of the city. Not surprising, but quite nice to see that. You can also see in the pH that the activity must homogenize, so we have a continual turnover of soil perhaps in in the urban environment. So how that then buffers against change, we mobilise, changes in rainfall patterns perhaps, don't know. Yeah, it's a big question. The strength of inputs and the sort of the buffering capacity depend very much on the location and the history of the use, the parent material, the climatic conditions, and urbanisation.
So I think we'll have to stop there because we're running a bit late, I'm afraid. But thanks very much to all the speakers in this session, and I think what we've taken away is that we're getting to the point where we have those data sets now that the real added value is going to be bringing them together, whether it's to look at the subsurface or to look at relationships with health and these other factors. But if I